Hello, my name is Chris Martin with the Biomedical and Engineering Technology program here at St. Philip's College. And today we're going to be doing a video of the preventative maintenance procedure for the Burdick 8500 electrocardiograph. The equipment we will be needing for the preventative maintenance procedure is the electrocardiograph, a set of ECG leads, and for the safety analyzer we're going to be using the Fluke ESA 612. And to run the answer software that goes along with the analyzer, we're going to be needing a computer. The first step in the preventative maintenance procedure will be the visual inspection. First, we're going to take a look at the general overall appearance of the device. We're going to be noting the condition of all labels and placards, and we're going to also look at the condition of all the buttons. Lastly, we're going to take a look at the electrical cord. From the visual inspection, we can see that the condition of the device is satisfactory. And we can now move forward to the next step. The next step will be checking the functionality of the battery. In order to test the battery, we first need to make sure the electrocardiograph is plugged in. We can verify this by the letters AC on the bottom, meaning that it is receiving AC power. The next step is to unplug the device from the wall. With the letters BAT at the bottom, we see that it is running on battery power. We need to make sure it will function normally on battery power for 1 minute. After a minute has passed, we plug the device back into the wall. We see the letters AC here indicating that it is running back on AC power. With the battery check complete, we're now going to test the printer functionality. To do this, we'll be printing a test page in order to verify that all the characters print evenly across the page. To do this, we're going to press Setup, and we're going to scroll down to Service Function. We're going to proceed to Service Functions. And we're going to select Printer Test Sequence. With that complete, the next step is to check the print head resistance. In order to check print head resistance, we need to verify the resistance matches the printed resistance label in the battery compartment. To check this, we first need to open the paper tray. With the paper tray open, we can peer inside this window and see the value 1122 written. That number is the print head resistance. The second part of verifying print head resistance, we're going to go into the service menu again. So to do this, we hit Setup, Service Functions, proceed to Service Functions. We're going to scroll down to print head resistance. I'm going to select that, and here we'll see the value 1122. So it matches. With the printer checks complete, the next step is our electrical safety test. To do this, we will now bring in our Fluke safety analyzer and computer. The first step of this is plugging the ECG leads cable into the electrocardiograph. To set up the safety analyzer, we're going to be plugging 5 ECG leads into the ECG ports on top of the device. We'll be using RA for right arm, LL for left leg, LA for left arm, RL for right leg, and V1. With the ECG leads plugged in, we will now plug in a USB cable into the side of the analyzer and then plugging it into the computer. Now that we have all the proper cables connected to the devices, we can now power on our analyzer and computer. Now that we have all our cables plugged in and devices turned on, we can run our software. We're going to be using a template that we created with the Answer program. We use this to check the leakage current of the device. So we're going to launch the template right now. The first screen here is the device under test information. So here we're just going to fill out the serial number, manufacturer, model, and location. Once we have all the forms filled out, then we can proceed. Our next screen here is the testing template. The start button here will begin the test for the electrical safety check. So we're going to start it now. It shows it here that it's communicating with the safety analyzer. You will have some pop-ups from time to time, but they automatically close. The values we're looking for, the high limit for leakage current is 10 microamps. So anything less than 10 microamps is good. And we're just going to let the test proceed. It takes a few minutes. Alright, our electrical safety part is done, and we're coming to a checklist here that is from our visual inspection. And we did it earlier, so we know that the power cord is good, the battery's good, it is in good condition, as long as the buttons and labels. So we have all that filled out, and it shows that it is passed. And here's our final screen. Our limit was 10 microamps, and everything here shows well less than 10. So everything checked good. Now that the electrical safety checks are done and the visual inspection is done, we can now power down everything and disconnect all the cables. This now concludes the preventative maintenance of the Burdick electrocardiograph. This has been Chris Martin. Thank you for watching.